Hello, am I audible? Yeah, good. So, hello all, I'm Kaushik Rishi. I work as a software engineer at Salesforce Hyderabad. And so, the today's talk is going to be mostly around writing sustainable or maintainable async API generator templates. So that's what we'll be talking about. And yeah, I already gave my intro. Yeah. So the agenda would be, I'll just before we talk, like go into the talk, I haven't planned much around the talk, so it's going to be I'll just take it as it goes. So, how many of you are familiar with the async API generator? Okay, that's at least 15% of the folks. That's good. So Async API generator is a library from Async API. It has around 40,000 downloads per week on NPM. And so that's one thing. And how many of you have idea about generator templates? Okay, that's again 15%, which is pretty good. So yeah, I'll just tell what about the tooling around it. So yeah, so async API, it's not just an API specification stuff and all. Apart from that, it provides a lot of tooling around the API specification. You have, for example, the spec first framework, Glee, and you have a lot of other stuff, like you have code first stuff, spec first stuff, and you have documentation generators, code generators, mocking and testing libraries, you have the CLI, and the bundler, of course. So this part that I'm going to talk about, it's going to come under the generator concept, generator and code generation. So as we all know, so whenever we write, let's say we build some EDA project, something that's event driven, we basically go ahead and write the async API spec, right? But this is like sort of a code first approach. You write the code and then you write the spec. But let's say you go ahead and just write a small spec, and then you want to like after you write the spec, let's say you want a project spinned up for that specific spec. So what would you rather do? You would just like see the spec and write your own project around that, right? So the code generators and generator templates, they work in such a way that, let's say you have a spec already, you can just run the generator on that specific spec to generate a working Node.js or Golang or Java or Python code, which will right away work with that spec, with all that events, channels, and all everything integrated. So I'll just show an example about what template actually is. So we will come to this again. So yeah, what actually is a template? So irrespective of async API, I'll just say what a template is. So let's say this is our actual template. So it has a couple of placeholders in between the file. So the entirety of the file is going to be constant, but whatever these placeholders that are there, they are the variable parts. So you can feed some data into the generator and also give this template to the generator. So what that will actually do is, let's say we have the topic and message published, two variables here. And we have the topic and message published, two placeholders, template placeholders here. It's going to take this template, feed those in here, and generate a new file. So that's what the generator actually does. So this is actually called a template. So this is just the basics around what template is. Have you guys heard about templating engines like Jinja, Nunjux, stuff like that? Yeah. So that is what actually generator is using. Yeah. So where does the generator fit in? So as I told, we have a spec and we are generating an entire project from that spec. So what generator actually does is, you have, I'll just say a simple flow. This is what you find in the documentation. I've just simplified it to a normalized flow. So let's say you write a new spec file called asyncAPI.yaml, and then what actually happens inside of this flow is that the spec file goes through the parser, and the spec is actually human readable. And once it goes through the parser, it'll turn into an object. It's sort of a document object which has the entire data about how the spec actually is. And then on the other side, we have a template, right? So what generator is going to do is, it's going to take in the template and it's going to take in the document object, and it'll basically do its magic, whatever it's going to do, and then you'll have an application in the end. That is a running application. So I'll just show how it works. So yeah. So it's sort of a small hands-on or a live demo, you could say. Yeah, is this visible? Should I zoom in more? Okay, cool. So this is a very simple specification that I picked up from the AsyncAPI website itself. The streetlights example, I've modified it to make it even more smaller. So we just have the streetlights API, and it's going to use the mosquito because that's the most simplest one we have right now. And so I've just defined one channel here, that is the light measure channel. What it's going to do is, it's just going to like sort of subscribe to that specific channel, streetlight slash event slash light measured, and whatever data is going to get pushed into that channel, we are just that is the spec right here, nothing else. So if you look at the message, it's the light measured message. It has something of this sort of a schema. It just has one field, that is lumens, which is an integer that represents how bright the light is. So that's pretty simple right here. So now, let's say I want to prototype this. I want to take this spec and write a working code for this. I would just open a new project. I would install all my libraries that work in sync with Mosquito, MQTT, if I'm using Kafka, I'll be using that Kafka, and all that libraries, and I'll write some files, some set of files. Oh, okay. Some set of files which will make it work, the project, and then after all that effort, that is when I'll be able to listen to the calls. Basically, whenever something is published into that channel, that's when I'll be able to consume it. So instead of doing all of that, we already have templates inside of AsyncAPI ecosystem that template developers already wrote. So what that actually does is, you have the template, and you use the generator, you give it the spec, it's going to generate a working application. So that's what we'll be seeing right now. So just zooming in. Is that visible? Or should I zoom in more? This works? Yeah. So we have the spec file here, it's the spec.yaml, and let's not just get into what templates are and how they look like. Just think of them as already written code with some placeholders that can just fit in your spec and generate a working application. So now I'll use the AsyncAPI generator CLI. This is AG, as you all know. So I'm going to input it the spec file and just force write flag just for safety. Yeah, so this command is doing nothing but it's taking the spec and it's taking the template input, like the template slash old Node.js template. We'll see later what the old and new templates are. And then it's going to output it into a new directory called as old library. So let's just run it. Or more specifically, we could call it old app. Yeah. So once I do it, as we see, the AsyncAPI file has been fed into the template, and we have a running application right now. So if I just go into the old app, you can look at all the files that have been generated. I didn't do anything about these files. I didn't write these files. These are the ones that are coming from the template. So now, if I just installed the dependencies inside this project that has been generated, and I'll just run it and show you how this works. Yeah. So now we have all the dependencies in here. So now if I run this application, as you see, there's already an application ready, which is working exactly as our spec is defined. So now, as you see, it's already subscribed to this specific, channel or topic, which we didn't do anything about it. We just ran the generator on a template. Now, we'll check by publishing some messages into that channel if the message is actually received or not. So I'm just going to split my terminal. Yeah. So I'm just using the mosquito pub command, just the regular server. Yeah, this is the data that was supposed to go into the topic, number of lumens, how bright the light is. So now, when I send it, as you can see, it's received. So we already have a running existing prototyped application with zero effort. So that is the magic of templates. So now, if I take you through the template, how that template actually looks, I'll just show you. Yeah. So this is the template. I've included all these URLs in the presentation, not to worry. So the template looks something like this. I know this might look pretty weird. It looked pretty complex for me the first time when I tried to comprehend it. But all it has is nothing but placeholders. Like you have multiple placeholders with some data inside of it. And as you can see, if you just take a closer look at what's inside these double flower braces, you can just look at this channel.publish.id, and you can see like everything is something related to the spec file. So where is this actually coming from? That is coming from the data that the parser has generated. So the data that parser has generated, that's where it's actually coming from. So that's a small like information around how templates work and how the parser's data is actually coming into the template. So there are a lot of templates currently in the AsyncAPI ecosystem. We have templates for Golang, we have templates for JavaScript, Node.js, we have templates for Python, and all of it. But there's a significant problem with a lot of existing templates that are there. That is, a lot of them can be generated only once. I'll tell you what the issue is. So the idea is, so the template that I generated, I'll just open the template up. So this is the app that I actually ran. So the app is not just supposed to be a prototype, but it's supposed to include the user's business logic. So if I just go into handlers and this thing, so this is where I'm basically asked to implement my business logic. So what, if you just take a closer look, it's basically the handler that was called when the message was received in the publish, like when the message was published and my application received it, this was the handler that was called. So let's say I write some code here. Basically, I'm writing my own business logic. This could be anything, like basically it could have something like I'm receiving an ordered placed event and I'm sending out a notification to the user. So let's just have it like, I already have some snippets saved. Yeah. So now, if I run this application, yeah, it's already running. Now I'll try to publish a message to this specific channel. And as you can see, my business logic is what was called. This is the subscribe middleware being hit, and the received message is so and so. So this business logic is actually included in the template for now. So what's the issue? Everything is working fine. There's no problem. You can include business logic. You can run the app. The app is running fine. You can add version control and do whatever you want to it. But the issue is, let's say, the business logic is actually currently coupled into the templates code. So let's say for now, like this is my current spec file. Yeah, this is the spec file that I currently have. Let's say going ahead in the future, I want to add another channel into this spec file, a new use case, and then regenerate my template. That could be a possible case, right? So we'll just simulate that. So I'm just going to take another use case, a new use case. This is basically a new spec file. I'll just show you what the spec file actually means. Previously, we just had this specific channel, the light measured one. But now, we have another channel, which is basically nothing but, it's taking the charging of the street light. I've just simulated some examples. Streetlights don't have charging, but yeah, let's just assume that. I'm also being like listening for charging measured event in the street light, and this is troubling. Yeah. So now I have my new spec file. So now if I try to regenerate the application, regenerate the template using the AG command, so let me just go and run the same command. This is just the same command from the history that I'm actually running. And when I run it, there's something that you'll see that has changed in the project that was generated. So this is the project that was generated. Yeah. So the handlers are in place. As you can see, previously we just had one handler that was handling the light measured event. Now we have two handlers. One is for charge measured and one is for light measured. But the issue is that the template couldn't differentiate what the user generated code was and what the basically what business logic you have implemented or what code the template has generated. So what it did is it basically rewrote the file, and the entire code that was supposed to be there, your business logic, it's gone. So ideally what you were supposed to do is you had to copy this template, generate a new template, copy all your business logic from that template to this template, which is not very ideal. So we come up with a sort of a new way to write templates. This is specifically for template developers. So the way that I showed you, it's an inefficient way to develop templates. So the problems with this approach are the user code is too coupled with the application code. That is one thing. And so once you generate a template, they can't be regenerated without the user losing his business logic. That is the second issue. And let's say you want to publish your template as a library and push it to NPM or whatever. That can't be done either. So eventually, all these points would actually lead to nothing but difficult maintenance. So yeah, what is the suggested approach? So like this talk would be more of like 40% async API and 60% around like what design your templates have to follow. So the suggested approach would be something around inversion of control. Anyone of you heard about inversion of control before? Yeah. So inversion of control is sort of a concept that a lot of frameworks use. That is the actual difference between a library and a framework. So how frameworks work is, you give them some piece of code. The framework takes that code, it plugs it into its runtime, and you don't have to worry about how it's plugging in the code or how it's executing the code. So this concept is called inversion of control. It will give you sustainability, maintainability, and pluggability, which is a very major concept of what we are trying to attain. So what we are trying to attain is the template that we are generating. The template, we want it to be similar to a framework. So where you can just plug in your business logic. Instead of going into the template, going into the handlers folder, and changing all that code inside of it, you could rather just use the framework as a library. You could just use the library as a framework and then plug in your code. And it will automatically ingest that business logic into itself and run the code. So the old template that I've showed you, we basically refactored it and converted it into a new template that follows the inversion of control principle. And I'll show you how it actually works right now. Yeah. So this was generated using the old Node.js template. So in the same way, I'll generate another project using the new Node.js template. As you can see the difference in path. And I'll call it new app, or yeah. Yeah. So once I run it, we have generated a new app as well. So if I just go into my project folder, so this was the old app, right? And now we have the new app. So the idea is, how did we write our business logic in the old app? We went into the application, we went into the handlers, we opened a specific handler. And inside that, there was a function which had the comment that ingest your, like, implement your business logic here. And then we edited that and wrote our business logic there. But that is not the ideal way. So now, as this template is developed using the ideal way, we're not going to touch it at all. We're not going to open the new app folder at all, except for the fact that, let me just install the dependencies inside the new app. Yeah, that'll just go on in the background. So we're not going to touch it. Then how will we ingest our business logic into the new app? So I have a file. Yeah. So this is the ideal design that we are expecting. This is the same thing that I did previously. Go into the file and write the business logic there. Now, as we have the new app as a library, as a framework, we are able to just import that thing, like we are able to import the new app and get the client from it. And here what I'm actually doing is, I'm doing nothing but I'm basically registering my middleware into the framework. This is what I told when I was saying like we should ingest the code into the framework. So now, as we have ingested the code, I'm going to run this just index.js file. Yeah. And as you can see, once I ran the file, we already have both of them ready, right? So now, if I basically hit this application with the same message through the topic, yeah, I'm going to publish event to the light measured, and as you can see, my business logic is called there. And now, the difference is, let's say, I take my new spec. Basically, I'm updating the spec now. I updated the spec. This is not the old spec. And the difference is, let's say, I run async AG. Yeah, and regenerating the new app. Yeah, and I'm regenerating the new app. When I do that, yes, my new app folder has been rewritten entirely with new handlers and new routers and everything. But as we decoupled our code from the new app, the business logic into this sort of a different file, and we are importing the new app, our business logic is not lost at all. So now, along with registering a light measured middleware, I could simply register another middleware, which is basically for charge measured. And we didn't have to touch the template at all. So this is what we mean by when I say maintainable templates. You can change the spec, you can modify the spec, the template will be regenerated, and your business logic won't be affected. So I could just have something similar here. Just a second. So this is the, I'll just call charge measured middleware being hit. Now, we could just run the application again. Let me just install the dependencies. Yeah, we could run the application again, and it's ready to accept all the events to the previous channel. This is the light measured channel, and we got the middleware being hit here. And we'll also try with our new topic, that is the charge measure topic. Charge measured. I'm going to give it a charge of, let's say, 15%. And I hit enter. And as you can see, we have even the charge measured thing here. So this is how basically our newly generated or new sort of a, what do you call, architecture for our templates should look like. And this is how they should be used like. To get into like how we made this change, you could basically contact me. There's also an issue link in the slide. So basically the simple idea is that you expose an API from the template, which is basically doing nothing but, let's say, simply if we talk about here, our framework is keeping track of middlewares that we are pushing into the code. It's just like how Express works. In Express, you do app.use, stuff like that, right? It's similar to that. You maintain an array inside your framework, and whenever you say register so-and-so middleware, register so-and-so middleware, this function is basically going to be pushed into the list and called when that topic is being hit. So yeah, this was about the templates. And yeah, we already did the live demo. And these are the major repositories. Inside the Node.js template, you can actually see an issue where we actually migrated from the old architecture to the new architecture. And that was all about the generator as well. And yeah, that's pretty much it. Thank you.